So we have the differential equation. We got a capital T, we got a lowercase t, but they're different variables from one another, so that's okay. Still the same idea. The initial condition we hold on to until after we've integrated. So let's get our capital T's on the left and our lowercase t's on the right. It doesn't look very easy to do, at least at first glance, but what we can do initially is subtract off the k times t minus 70 dt from both sides. So it's just going to look terrible, but this whole thing. So this is me subtracting it from both sides, so it doesn't look so good, but that's what it is. So dt would be equal to negative k times t minus 70 dt. All right, cancels on the left-hand side. On the right-hand side, it exists now. There's something there. All right, I still have that capital T on the right, though, along with the lowercase t. I don't want that. So what could I do? Divide by t minus 70. So we're looking at 1 over t minus 70 d capital T equals negative k d lowercase t. That k is a constant. We don't know what it is. Some unknown constant related to whatever this physics situation is. It happens to be Newton's law of cooling, but we haven't covered that yet, so we wouldn't necessarily know that. We just know that it's not a variable. All right, so just like the last problem that we did, we're going to integrate both sides. What's the antiderivative of 1 over t minus 70? ln t minus 70, yep. On the right-hand side, antiderivative of negative k.
X.
Negative kx under normal circumstances, in this case, negative kt, lowercase t, plus c, because there is some constant of integration that would emerge through the anti-differentiation process. All right, we want to solve for capital T. We want to try to clean this up as much as possible before we get into the part where we apply our condition, because ultimately we want to figure out what the c value is. So I'm going to rewrite this as log base e of t minus 70 is equal to negative kt plus c. And convert it over into exponential form, in which case I'm going to get t minus 70 equals what? Exactly, e to the negative kt plus c. The right-hand side can be changed. Instead of having it as e to the negative kt plus c, how else could I write it? Close. You got the right components, not plus, times. All right. Now, what is e to the c equivalent to?
C.
C. So this would be the same as saying c e to the negative kt power. The the left-hand side, we had it as absolute value of t minus 70. But because that c is there, that absorbing constant c, we can drop the absolutes. All right, so it becomes t minus 70 equals c e to the negative kt. We talked about this, but it was a while ago. The idea was that if this were written in a different form, it would be plus or minus t minus 70, in which case when I divide that out, it would get absorbed by the c. So the plus or minus becomes irrelevant. All right, so at long last, I get a clean-ish looking answer. t equals ce to the negative kt plus 70. So that's the general solution. I need the particular solution. That particular solution is based off of a condition that they gave us. I don't want to scroll back up, so can you just tell me what that condition was? 140. All right, so this is a condition. All right, so 140 would be equal to c e to the negative k times 0 plus 70. What's e to the negative k times 0 going to be equal to? 1. So this is really saying 140 equals c plus 70. So what's c? 70. So final answer, took a while in comparison to the last one that we did. 70, t equals 70 e to the negative kt plus 70. All right, so you get a look at how easy it can be and how difficult it can be. You also get a good sense of why group assessment rather than individual assessment. All right.